When we last left you, we had just pulled in some LAS data from our LAS file, and we've assigned the mnemonics from the LAS to log parameters that TIPS will be able to use to help create synthetics in a full suite of modeling activities. And then we had on the charts, and we noticed two things. First of all, we've on several of these charts, we have these big pink areas. We also have these little orange flags next to them that tell us that we're missing some data. We need to fill in that missing data. So we're going to do a little bit of that, and we're going to focus on just one of them for right now. So we have our sonic log over here, and we can zoom in as we showed a little bit. I'm going to zoom in on the top, and we can see that this information for this log starts at about 1,200 feet. And the reason is typical. The sonic was not logged in that shallow region, but according to the LAS file, this well log starts at about 800 feet. Okay, that was the first depth that was measured. Obviously, have resistivity, and I need to know what's in here, or I need to effectively, for the sake of modeling, push my modeling initial depth down, which I could, but I'm not going to do that right now because I don't want to lose any data that we don't have to. So how do we fill in this missing data? We're going to edit this curve, and I'm going to edit the sonic curve. And the way I edit the sonic curve is I go back to my tree, and I click on it, and there are two ways to do it. I can go curves, edit the curve, and it's going to edit whatever is selected, or I can right mouse on it and say edit curve data. And when I do that, I'm going to get a window that pops up. Now this is just for editing the sonic data. Now when we edit curves and tips, we do that in a concept of edit zones. So we edit a zone, which is a depth range. And right now we have one of the things we want to do is take care of this missing data. Now one nice little thing that we have in here is I've got a little flag down at the bottom of this menu that tells me I'm missing data at 800 feet and also down at 10,899 feet, which I didn't really realize. A lot of times we're just missing that single data point. We want to take care of it. So we want to create an edit zone. So in the top of this menu, we have what looks like a spreadsheet that will create of all the edit zones that we might apply to this curve. Now we may apply one type of edit, we may apply 30 types of edits. It really doesn't matter. It just depends on the quality of the curve. And we can change the sequence of those things if it's important. Right now we're going to focus on the real simple editing of the curve to take care of some of this missing data. So I know that I'm missing data in this pink region, and the black line is showing my actual curve. I'm going to zoom in right around here. Okay, and you can see from about 812 feet I have no data, and then my sonic picks up there. So I need to fill in that data. So I'm going to go to new. I need to create a new edit zone. Two ways to do it. I can click across on the spreadsheet. I don't have any edit zones defined yet. Click on that to get started, or there's a little toolbar right here that will allow me to add the edit zone. So I'm going to click on that. Okay, now you'll notice my cursor changes this crosshair. So I'm looking to drag. So I don't have to be too precise because I can always edit that. I'm just going to drag from here to down here. Okay, now what I'm doing now is defining the edit zone. So I'm going to go from 808 feet to 1,203 feet. And again, it's going to be real easy to change that. Then what is the edit method? What are we going to put in there in this case? Sometimes we're actually editing data, sometimes we're filling in data. So the edit method that we have available to us at this point is average, which will take the average value of over this whole range. We could enter a value. We could do a linear data shift, ramp shift, calculate, and we'll get into more of these later. For right now, I'm just going to put in a linear, and I can shift the whole curve. I'm not going to worry about it now, and I'll hit accept. And what it does is it then says, okay, I'm going to take the last data point that you have there, and I'm just going to drop it all the way to the top. Now notice I still have missing data because I told to start the zone at 808 feet. Now I'm going to click my cursor up here to get away from the crosshairs. A couple ways I can modify that zone. I can click on this and drag down. I can drag up to the top. All right, so now I have this data going all the way to the top, and I'll notice in the spreadsheet up here it shows that. And if I scroll down a little bit, down to where this curve started, I'm going to pick the bottom edge of this edit zone, and I can move it, and you notice it's just picking up that data. And you're probably thinking, oh, this is not good. We're modifying the LAS file. No, we're not. What we're doing is we're defining the edit zone that's going to sit on top of it. Um, and so now I have data. I'm going to zoom out just a little bit. Okay, so I have a linear value there. It's picking up the last good value in that curve and putting it there. If I zoom out just a bit and I look at this, I go, well, I really would prefer to have that value over. I can take that edit zone and I can shift it. I can shift the whole thing, or I can just shift the top. I can shift the bottom. If I shift the bottom, I'm going to hit these little cursor here, and it's going to shift it like that. Oh, that's kind of neat. Or if I want to shift the whole thing, I can do like so. Okay, I'll go back to it. So we've defined this value to fill in that missing zone. And we'll notice down at the bottom it says we're missing data at 10,899 feet. So we're still missing some data. So let's go down to the bottom. I'll zoom all this way, and then I'm going to dynamic zoom, and I'll go over the bottom, and I'm going to keep zooming in, and I'm going to see this is one of those little annoying things where the very last data point where we had other information such as resistivity like had data, but the Sonic did not. So we're going to do the similar thing. We're going to create another edit zone, and we're just going to go from this point down to the end, and we'll do a linear value again, and then it pops it and fills it in. I have no missing curve data. And if I zoom to everything, you'll see now where we filled in data, it's in gray. And I'm going to hit accept. I go back to my Sonic curve, and I see that data right there, but now it's in gray. So what that's telling me is that zone has been edited. Okay, so we've filled in the missing data at this point. Now, before we go and we'll create some more curves and do some more sophisticated editing of the data, I want to show you some more of the controls on how we can view this data. So we can see we're looking at the Sonic, and we're looking at it from 50 to 200 microseconds per feet. How do we get those scales? Well, we just simply click on it. If you put the mouse over this chart header, it says mouse left to change the scale, mouse right to change the parameters. So I'm going to click on mouse left, and what pops up is this scale settings menu that you'll see throughout tips. Right now, by default, when it reads the data in, it's set to auto scale. So it reads the data, adjusts it as nicely as possible, and shows that. If I don't want it to be on auto scale, I check that box, I uncheck that box, and I say, I just want to look at the value between 100 and 200, and I want every step at 20 decimal places, and I want this to be blue for the sake of it. I can show the values in reverse. I can put it on a log scale, and I can also give it a scale factor. This gets very handy when we get into velocities and we're looking at tens of thousands of feet per second. So now I'm going to hit accept. So now the scale goes from 100 to 200, and it's in blue. Now you'll notice the min and max are shown in bold, and that's an indicator to me that those have been specified. They are not auto scale. If it's not boldface, then it's auto scaled. Now we're going to go to the resistivity. I'm going to show you one other bit that we can do here, because resistivity is one of these where we usually like to look at it on a log scale. So I'll click on that, and I'll leave it on the auto scale for now, and I'll leave everything fine. But I'm going to come down here and say put it on a log scale. Boom, log scale. So now I'm looking at the log of the resistivity, which is generally what we look at. One other one that I'll show is our neutron porosity. A lot of times we like to look at that on a scale that's reversed, and we always, because we may overlap it with the density porosity to help us pick some hydrocarbon zones. So I'm going to pick on that, and I'm going to turn the auto scale off, and I'm going to tell it to go from 0 to 0.6, which is what it currently is. But I'm going to tell it to show it in reverse, and I'm going to put it as blue as well. Okay, so there's our neutron porosity. We're missing data at the top, but it's in blue, but it's going from 0.6 to 0. That'll come in handy later. All right, so I'm going to show one other thing. We have the bulk density curve shown here, and that's missing a lot of data. We could go in and fill that in the same way, but there's some additional ways that we can estimate the bulk density that we'll come down to. Now, it's always a good idea to save, so hit the save icon and save it so that if I close it down and restore it, I'll be looking at what I have right here. Now I'm getting all excited and I want to create some synthetics. So I'm going to go to synthetics 1D model, and it says you don't have any data for a P wave. You need a P wave. How do we get a P wave? That's going to come under the custom curves. We've got a sonic, but there are multiple ways that we could create a P wave. Sometimes we have to do a pseudosonic based off resistivity, but for right now, we need some information on a P wave. The next video, we're going to show some custom curves, including P wave and a really exciting one on shale volume.